Great to be here. I'm Dan Stack, co-founder and CEO of Electrified Thermal Solutions. We're an MIT spinout. I was working here since 2014 under Dr. Charles Forsberg in the nuclear energy department. And we founded the company to decarbonize energy industry with electrified heat. And the market pain point on its face is that if you are an industrial, really of any kind, you're usually burning fossil fuels. And if you try to get off of fossil fuels to something zero carbon, you will find no affordable option. And there's three main features to this challenge as we see it. The first one is that electricity, zero carbon electricity, has become quite cheap. Wind power, solar power are being deployed at record numbers. There's two counterpoints to them, however. The first one is that firming that energy is very expensive. That is, storing it in a battery for later. You'll easily 10x the cost of that energy if you want it firm and on demand. The other challenge is that industries are used to heat. Generally speaking, their heat demands are what dominates. And even if you had a perfect battery, it doesn't put out high temperature heat for your process, it puts out electricity. So how do we take that zero carbon electricity and make it into a firm heat source that's still affordable? That's what we've been doing at Electrified Thermal. We've been developing the Joule Hive thermal battery. And in essence, it is a box that sits on your industrial site nearby, and it takes in electricity whenever it makes sense. It could be from solar power, wind power, nuclear, hydro, or just the grid with those energy sources on it. We take in that electricity, and we put out high temperature, 24/7 gas, high temperature air or other gases that we flow into your furnace, your boiler, your kiln, and we can do the job of fossil fuels as we do that. We can deliver 1,800 Celsius. We're at least 3 times cheaper, than making hydrogen, which is kind of the de facto answer in a lot of cases. The less hydrogen you need, the happier you will be if you're trying to decarbonize. Retrofittable, we plug into your process, give you a pipe of high temperature gas into your furnace, into your boiler, into your kiln, so you don't have to radically redesign what you do to decarbonize what you do. And it's very modular. We can build larger or smaller boxes, and we can put multiple on a site. And as I'll show later, we also have other form factors. And our vision is industry electrified by 2045, which is roughly a $3 trillion challenge and opportunity. This is what it takes to transform our energy and industrial sectors. This is what we spend on fossil fuel today in these sectors. And so it's a massive undertaking, but we are aiming the Joule Hive thermal battery and the Joule Hive technology to be the engine of the future that has double-digit global percentages of energy flowing through it by this time. And what makes us different than other approaches to electrified heating and thermal storage is roughly 10 years in the making, mostly during my time at MIT, which is the electrically conductive fire brick. And so as we got to working on this problem back then, we came to understand that electric heaters are the bottleneck if you want to electrify industry. Electric heaters were never designed to replace fossil fuels. And why would they be? It didn't make sense before. And so what we did was we looked at materials that can survive. You know, other heaters, they oxidize, they burn out, they break down, they don't last long enough, and they don't go hot enough. And what we looked at was materials that can take the heat, can run at flame temps for decades. And so we developed electrically conductive fire bricks. I have one here. If you come by my booth and give me a business card, you can hold it. And we run electricity straight through these bricks and heat them up to flame temperatures. And so what you see on the screen here is what's inside the Joule Hive, and it's full of these bricks and regular fire bricks, and they can heat up to flame temps, and when you want the energy back out, you just flow air or other gases straight through the brick chamber, and it comes out hot. It's very simple, and there's nothing here that oxidizes, burns out, or breaks down. It can run on medium and high voltages, which is better for scale compared to electric heating technologies. And so we've checked the major boxes that we see as the limiters, and we've been scaling up. So I was here, I think it was 2 years ago now. We've made some big progress. We've gone now to our first multi-ton batches of these bricks this year. They're very similar, 98% similar to existing bricks. So we've worked with existing supply chains, existing manufacturers to produce these. Now whether you want 2 tons or 2,000 tons, we can make the e-bricks to scale up our tech. And they're very similar to what's used in the glass industry, as an example. As far as actually piloting the system, we've gone from a few hundred watts now to several tens of kilowatts in our elevator-sized box on the right. So the left is what we used to do, the right is what we do now. You can see me standing in there with some colleagues. And we've done cyclic heating. We've put out, it's hard to see here, but you can see the faint glow of the hot gas coming out the back. We've done cyclic high-temperature gas flows. We've also done direct metals melting in the bottom right. You'll see where we loaded metal in and does direct radiative heating for metals. A customer wanted to see this. And so our elevator-sized box here, we've been running this for about a year now, and what comes next is our megawatt scale system. And so we'll be deploying that early next year, customer sites the year after, and we're talking to folks that want steam generation, calcination, any number of furnaces that we're looking to hook up to in deep conversations. And ultimately, we'll be scaling to the hundreds of megawatts. So we go with first to kind of container-sized systems, and then we go to megawatt scale systems so we can service the entire industrial sector. Final quick point on economics. Can this save you money? Yes. And we can say that because electricity prices are getting negative, increasingly so as we deploy solar and wind power, near $0 electricity. And this is just over the last 5 years in the US. And I think I'm out of time here, so I'll jump to the punchline that we can save you money. Here's a quick chart of just 5 sample countries. On the left of each of these is our cost plus the cost of the Joule Hive. On the right is the natural gas price. And when we run in these different countries, we can beat natural gas prices now. It's a widening envelope of places where we can beat natural gas because of these trends. So come talk to me if you want to save money while decarbonizing, and reach out at, come to my booth or at these email addresses, and looking forward to speaking. Thanks.